Good day everyone. Previously discuss ta o nag-introduce ta about the subject structural analysis and tackle na to ang concepts. So for now, we will discuss about equilibrium and support reactions, and i-recall sab na to tong mechanics, okay? Statics. Okay, so first let us discuss what is equilibrium. So previously I gave you an assignment to illustrate something that is in equilibrium. Okay, so you will know that the structure you have presented is in equilibrium. So if it is at rest, and it remains at rest when subjected to a system of forces and couples. So meaning at rest, nara siya sa diha nga position, no, or sa kana nga place, dili siya mo move, and then it will continue to remain at rest even if nag-apply ka og forces and couples. So couple is another term for moments. Okay, so natay duha ka main types sa structures. We have the plane structure and the space structure. So for each types of structures, natay lahi-lahi nga consideration for them to be in the state of equilibrium. Okay, so maingon na to nga ang plane structure, a structure is plane if it is it has a coplanar system of forces, meaning all the forces that act on that structure is on the same plane, no? So like for example, x and y plane, you only have two coordinates. So sa mga examples ana atay beams, the cables, the frames, arcs, trusses. So those are plane structures. So plane structures are considered to be in equilibrium. So mostly sa inyong mga gi present sa inyong assignments, they are plane structures. So mo pa man po siguro ni ang na-discuss sa statics o strength of materials. Okay, so for a plane structure to be in equilibrium, it must suffice, no? It must meet these three considerations. So the forces horizontal must be, summation of forces horizontal must be equal to 0. And the summation of forces vertical must be equal to 0. So all forces that acting on the plane, if you sum them up, as long as they're acting on the same coordinate, no, or same direction, they must be equal to 0. And lastly, the summation of moments in that structure must be equal to 0. So that is for the plane structure. So for space structure, so dili man tanan structures, no, nga kuan is in plane, coplanar. Mostly sa itong mga structures gyud, once nga complex na siya or na siya combination na siya sa mga structures, they are considered as space structure. So they are not acting on one plane only. Let us say you have what do you call this, three planes, no? For example, first you have the x and y plane, but since three-dimensional siya, natay z plane. You have xy plane, you have the zy plane, and you also have the XZ plane. So 3 planes na, no? So wala siyang gitawag siya 3-dimensional. So examples of them are the tripod. The tripod could act, example lang ha, ang isa ka leg sa tripod na diri dapit sa kaninga portion sa Z plane. The other leg is on the X, and the other leg also is on Z, but the height acts on the Y plane, on the Y axis. Okay, so mo na siya ang tripod. So mo na siya 3-dimensional space structure. Okay, so for space structure to be in the state of equilibrium, it must meet the 6 considerations. It must have horizontal forces along X. The summation of the forces equal to 0. The vertical forces must be equal to 0. That is summation of Fy equal to 0. And the summation of forces along Z must be equal to 0 also. And then aside from the forces, for space structure, you must also consider that the moments, summation of moments, all the moments must be equal to 0. So if there is a rotation or moments along X axis, they must be equal to 0. The rotation also along Y axis must be equal to 0. And the moments, all the moments sum up along Z must be equal to 0. So that is for a space structure to be in the state of equilibrium. So in structural engineering, the most common structure that we encounter is the beams. So mga po medyo more complex to investigate, no, or to design, because siya ang isa sa mga main gyud nga mag-carry og loads. Siya ang mag-act nga structure to transfer loads from the floor to the column. Okay, so let us recall what are the basic types of beams. So first, we have the simply supported. The simply supported has a pin on the other side and a roller on the other side also. Okay, so it is supported at both ends. But it is free to rotate. We also have the cantilever beam. So that is fixed on the other side and free end on the other. Supported only at one end. Okay. Another type of beam is the overhanging. In a overhanging beam, it looks like a simply supported, but there's an overhang on the ends, no? Na free end, na ay certain distance at the end nga na kuan walay support, so pwede siya mo deflect downward, no, or upward. depende sa loads. Okay, that is beam with free end. The number 4, we also have fixed-ended. So sa fixed-ended, both ends are fixed. To resist rotation, no? So both ends fixed to resist rotation. So later atong i-discuss no ang different types also of support reactions, or I mean support structures. Unsay purpose or unsay effect kung naka-fix, naka-hinge, naka-roller. Okay. So number 5, we have the prop beam. Prop beam is also a cantilever beam, but it has a support on the other end. Could be a hinge or a ruler. So dili free end, no. Cantilever beam free end ang isa. So a cantilever beam with a support at the other end. For last, at ay tawag na continuous beam. So it has more than 2 supports too. So minimum is 3 supports. So extended more than 2 supports. Okay, so these are the types of beams. So let's move on the types of support structures. Types of support structures. Okay, so number 1, we have the hinge, or also known as pinned support. We have the ruler. We have the simple support. We also have the fixed support. And lastly, we have a cable support or link. Okay, so sa man ang hinge or pinned. So kani siya either bolted no or welded. So dili siya free siya to rotate. Sample mo na siya ang beam. Before ta mo move sa roller, so atong kanon ang yang reactions no. We have vertical and the horizontal. So mo na siya mga reaction forces or mga loads nga gina-resist sa support, no, vertical and horizontal. Walay moment unless ang moment is applied moment, pero the structure itself has no moment. Wala siya i-resist na moment kay free man yung rotation. Okay, so for the roller, ang roller support pod so free siya mo move upward. So ang yung resistance is only a vertical support lang, no, vertical loads lang yung i-resist. For simply supported also, mura ra siya og tungtong o vertical lang gihapon ang ihang i-resist ng force or ang reaction. For the fixed support, ang iyang gina-resist is we have the vertical, the horizontal, and gi-resist po niya ang rotation. So ang effect niya is napugkay moment. So vertical and horizontal, those are axial forces. So both axial forces and moments iyahang gina-resist. Kani vertical lang, kani vertical pod, kani horizontal and ang hinge horizontal and vertical. So those are axial forces. Okay. For number 5, the link or cable. By the way, sa fixed support actually wala na siya ingon nga ipilit ra na, no. The kuan gina na ang tinuod gina na is na siya extended nga structure nga murag na lubong siya, mo na fix siya, naka-embed siya diri sa pikas nga side. Dili lang na to ginapakita, no. Ka-embed siya. Or fixed support could be a continuous support, like example continuous beam na kay column diha, continuous siya. So diri nga support fixed gyapon siya, no, na kay vertical, na kay horizontal nga loads or reactions, na po kay moment. For the cable and link, main gina-resist is tension, tensile force. Iba sa atong strength of materials atay tension and compression. Tension is the force that tends a structure to pull the fibers, no, to pull the structure itself, while compression tends the force to shrink, to compress. If there is an action, there is an opposite and equal reaction. Okay, example ani mga ropes, hanging objects like suspension bridges, no. Okay, so mali siya mga types of support structures.